Welcome to today's lecture on solving linear equations. What we're going to do first is go over simple linear equations with one variable, such as the problem that I have here. So what I'm looking at is I have 5/2 x minus 1 is equal to x plus 1/4. Now, I know a lot of people don't necessarily love fractions, so what we're going to do is we're going to go ahead and clear these fractions. And the reason we can do this is because we are working with an equation. So what we need to do is look at all of our fractions, check out the denominators. If we can find a common denominator, we're going to use that common denominator to multiply everything in the problem. This will effectively clear our fractions for us. So I'm looking at my denominators. I see I have a 2, I have a 4. So my LCD is 4. That is my least common denominator, is 4. I'm going to take 4 and I'm going to multiply the entire problem by 4. By doing so, I have 4 times my 5/2 x minus 4 times my 1 is equal to 4 times my x plus 4 times my 1/4. Now, by multiplying by 4 to both sides, I'm not really changing my problem. All I'm doing is manipulating. So we are going to now clear these fractions. 2 can go into 4 2 times. So this is effectively 2 times 5, or 10x. This is 4 times 1, so 10x minus 4 is equal to, I have 4 times x, plus 4 can go into 4 perfectly 1 time. So this is effectively 1 times 1. Now my new equation has no fractions. And what that means for me is I can go ahead and start combining my like terms. Notice that I have a 4x on this side, I have a 10x on this side. What I need to do is simply combine my like terms by moving them to the same side. Now, it doesn't necessarily matter if you want to move left or right. However, I like to keep my variable positive for as long as possible. So I'm going to subtract 4x from both sides, and I'm going to add 4, because there's no variable here, to both sides. 10x minus 4x, that gives me 6x. These terms canceled, that's why we moved it. These terms cancel, that's why we moved it. And then I have 1 and 4, which is 5. At this point, to isolate the variable, you need to divide by 6. And so you get a final response of x is equal to 5/6. And that's it. That is our solution for this problem. Let's try another problem. I'm going to need to get board space. My next problem, oops, I forgot to erase that. There we are. My next problem involves decimals. I have 0.60 times a quantity of z minus 300 plus 0.05z. If you're wondering, I am referencing my notes, so I make sure I copy the problem down correctly. It's always a very important step. Minus 205. Good. So my new problem reads as 0.60 times the quantity of z minus 300 plus 0.05z is equal to 0.70z minus 205. Now, just like the last problem, where most people don't necessarily like fractions, most people don't like decimals either when they're working in math. So we're going to go ahead and clear all of these decimals. And again, we can do this because we are working with an equation. If you are not working with an equation, don't do this step. However, we're working with an equation, we want to clear our decimals. What I need to do is identify how many decimal places I need to clear. In this case, 0.60, well, that's really like a 0.6. That's really only one decimal place. Here, 0.05, that's definitely two decimal places. And here, 0.70, that's, again, just like one decimal place, because that 0 at the end would fall off. So in total, I need to clear two decimal places throughout my equation. To do that, we're going to multiply by 100, because anytime you're clearing a decimal, you're going to multiply by factors of 10. So 100 clears two decimals. So we're going to multiply this entire problem by 100. Now, what that does for me is it clears my decimals through each one of these products. And so this is one product right there, because I have 0.060, times a quantity. That quantity is a whole component with that 0.60. So when I multiply here, I clear my decimals. I have 60 times z minus 300. When I multiply here, I get 5z. I cleared my two decimal places. As you can see there, it's two decimals. Okay, and then I'm clearing here. I have 70z. And I have no decimal places here, so 100 times 205 is 20,500. Great. Now we have no decimals through our new equation. Again, all we're doing is manipulating, so we haven't really done anything different at this point. What we do need to do at this point, however, is start rearranging. We got a couple steps that we need to do here, and we see some z's throughout the problem. So let's go ahead and take that. So if I have 60 times these two pieces, 60 times z is easy, that's 60z. 60 times 300, I encourage you to always use calculators when you have them at your disposal. That way you're not getting confused on your calculations. But 60 times 300, we are looking at 18,000. Plus our 5z, nothing changed here, is equal to 70z. And nothing changed here, minus 20,500. Okay, we got a lot of z's in this new problem, now that we've simplified a little bit. So we want to combine our like terms. You can go ahead and just take this step right here. You have 65z minus 18,000 is equal to 70z minus 20,500. Now we need to combine our like terms. Again, I like to keep my variable positive, so I'm going to subtract 65z from both sides here. Effectively, in this spot, 70 minus 65 is going to give me 5z. On this side, I have 20,500 and I'm going to move it, so I'm going to add 20,500 to both sides. Negative 18,000 plus 20,500. Don't forget to include your signs. If you ever drop a sign, just go back and look at your problem. Make sure you're not losing any of those signs. It happens a lot with negatives. So negative 18,000, positive 20,500. We're going to go ahead and combine those. That is 2,500. Solving for z, we have to divide out. We are going to divide 5. And so I get z is equal to 500. And that would be my final response for this problem. Now sometimes I get a question, does it matter which side the variable is on? And the answer to that is no. What you're looking at is 500 is equal to z, or reverse that, z is equal to 500. The whole point of an equation is that it is balanced on both sides. So you can have that variable on either side. Okay. Now, let's try another problem as we're solving through our linear equations. So of course I need to get some board space before we move on. There we are. Make sure it's nice and clean, that way we can see the board easily. My next problem, again I'm referencing my notes to make sure I can have it written down clearly and accurately. My next problem is a little bit different than what we've done so far. I mean, it's essentially the same concept, but you'll see what I mean in just a moment. Out of this plus 14. Okay, so my new problem reads as a -2 times the quantity of 6x minus 5 plus 4, and it is equal to a -12 plus 14. So at this point, what I'm going to do is I'm going to start by distributing here. Go ahead and clear that out. I don't have any fractions, I don't have any decimals, so I'm just going to go ahead and jump into simplifying my problem. So at this point, -2 times 6 is going to be a -12x. -2 times a -5 is a +10. Plus 4 did not change. This side, there's nothing to do, so we're not changing it at all. We're just going to bring it down. Combine your like terms. So I have a -12x plus this makes 14 is equal to a -12x plus 14. Now some of you may be looking at this step and saying, hey, wait a minute, they're exactly the same. I have a -12x plus 14 on this side, I have a -12x plus 14 on this side. So why are my equations the same? Rather, why are my expressions within the equation the same, to use proper terminology? Well, you can actually solve this out even further. So let's go ahead and take that step. Let's see what happens. So just because we're going to add 12x to both sides, because we canceled it here to move it over, and hey, look, it cancels there. Interesting. So that gives me 14 is equal to 14. Now I can technically move my 14s over and come out to 0 equals 0 as well. But 14 equals 14. The question is, when is that true? And the answer is always. 14 is always equal to 14. And that means in this type of problem, what we've come up with by canceling our variable and having an exact solution that's equal to itself, that means for our variable, we have all solutions. So it's a little bit different than what we've just had, where we came up to a precise value for a variable. In this case, all values are actually our solution. All right, very good. Let's do one last problem. Again, gotta get my board space. So, my new equation that I'm working with is a -5 times the quantity of 4y minus 3 plus 2 is equal to a -20y plus 13. Again, I don't see any fractions, I don't see any decimals, so what I'm going to do at this stage is start by simplifying. So I see I have distribution here. So we're going to work that out. So a -5 times 4 is a -20y. Negative 5 times negative 3 is a positive 15. Plus 2 did not change. This side, nothing's changed, so I'm just going to bring it down. Still combining my like terms. I have negative 20y plus 17 is equal to a negative 20y plus 13. Interesting. So it looks like my variable is going to cancel. Let's go ahead and just try this. So I'm going to move my 20y over. From this side, it cancels. And this side, it again cancels. So what am I left with? I have 17 is equal to 13. Interesting. When is 17 equal to 13? Never. So in this particular situation, because we have a false answer, we have 17 equals 13, and that never occurs, what we have for our variable are no solutions. Okay, thank you for tuning in for section 2.3. I will be continuing with section 2.4 in another lecture.